Okay, so in this video, we want to learn how to integrate something of this form, ax plus b to the power of n dx. Now, the key principle that you're really learning is that integration is the reverse of differentiation. The way we're going to start to think about this is we're going to review differentiating functions of this form. So let's say we want to differentiate 7x minus 1 to the power of 3. If we differentiated that, hopefully you remember that what we do is we differentiate the big bracket first. So we take the power of 3, we bring it down to the front, and we reduce the power by 1. So this is going to be 3 bracket 7x minus 1 to the power of 2. After we do that, we look inside the bracket, 7x minus 1. We differentiate that thing. We get 7, and we multiply through by 7. Okay, so to recap, to differentiate a function like this, we take the power of the bracket, we bring it down to the front, we reduce that power by 1, and we look inside the bracket, we differentiate, and we multiply through. Just do one more example just to make sure it's firmly in our minds. Let's say we've got 3 minus 2x to the power of 5. We differentiated that. Then we've got 5 bracket 3 minus 2x to the power of 4, right? Because we take that power of 5, bring it down to the front, reduce the power by 1. Then we differentiate inside the bracket, which gives us negative 2. We multiply through by negative 2. Okay then, well, integration is the reverse of this process. Let's try to think about what that would look like. If I've got the integral of 2x plus 4 to the power of 6, how would I integrate that? Well, I've just got to undo the steps. So I take this power and I add 1 to it. I get 2x plus 4 to the power of 7. And then I divide by that new power, right? So it's the basic step for integration, add 1 to the power, divide by the new power. Then what I do is I differentiate this thing inside here, which gives me 2. And now instead of multiplying by 2, because I'm undoing differentiation, I divide by 2. What we end up with is 2x plus 4 to the power of 7 over 7 times by 2. Of course, we've got to add the constant of integration, c. Well, let me just do one more example here. Let's say we've got 3x minus 5 to the power of 2, I guess. How are we going to integrate that? Well, get 3x minus 5 to the power of 3. We add 1 to the power. We divide by the new power. And then we differentiate the 3x minus 5. We get 3. We divide by 3. We add c at the end. Now, just a note of caution for you guys. When I say you differentiate inside the bracket and you divide through, this only works if the thing inside the bracket is of the form ax plus b. It won't work if you've got exponentials. It won't work if you've got sines and cosines. It won't work if you've got x squareds or x cubes, okay? When you do your A-level, you're going to realize that the way you can integrate things like that is using a method called substitution. But for add math, you're only going to be asked to integrate questions of this kind, right? So you don't have to worry about it. You can just take the coefficient of x here, divide through by that. But I just want to warn you in case later on when you do your A-level, you do the same thing and you wonder why it doesn't work. All right, well, let's do a couple of other examples. Let's make things a little bit harder. Let's say we've got question 1. You just want to integrate, I don't know, the square root of 4x minus 3 dx. And then let's do question 2, which is we want to integrate, I don't know, 3 over 5 minus x squared dx. Okay. Now, in both of these questions, the only thing that really makes them harder is we've got to rewrite the thing inside the integral in terms of our indices laws. So this thing becomes the integral of 4x minus 3 to the power of a half dx. Now, notice, please, one thing. The integral sign still remains. Why does the integral sign remain? Well, because we haven't yet integrated. Okay? We only get rid of the integral sign once we've actually done the integration, right? Until then, what we do is we keep it because the integral sign is basically saying, please remember we have to integrate this thing here. Okay, so all we've done is we've converted this to indices form. We haven't yet integrated, hence we still keep the symbols. All right, now let's integrate this thing. Okay, we're going to add 1 to the power. So a half plus 1 is 3 upon 2. We're going to divide by 3 upon 2. Now, dividing by 3 upon 2 is the same thing as timesing by 2/3. Then we differentiate the 4x minus 3. We get 4. So we divide through by 4. And of course, we've got to remember to add our constant of integration, c. Okay, well, let's try the next question, question 2. Again, we've got to convert this to indices form. So I'm going to do this nice and slow. This is the same thing as 3 times by 1 over 5 minus x squared dx. And then this expression here, the 1 over 5 minus x squared, that can be rewritten as 5 minus x to the power of negative 2 dx. Now, guys, notice, please, what I've done is I separated this 3 out from this thing here, because I noticed that lots of people then, basically, if you end up combining these things, then people don't know what to do with the powers. So I think if you split it up, then it's easier for you to, in your head, convert this to that, okay? If you're not so confident with using your indices rules, that's something I would recommend. Okay. So now we have actually got to integrate, right? So what are we going to do? Well, we're going to take our 5 minus x, we're going to add 1 to the power, so we get negative 1. Divide by a new power, so we divide by negative 1. We then differentiate inside the bracket. So if we differentiate 5 minus x, we get negative 1. Divide by negative 1. We've got to remember to add c. If we were to rewrite all of this, negative 1 times negative 1 is positive 1, so that doesn't really matter. So we've got 3 times by 5 minus x to the power of negative 1 is 1 upon 5 minus x. Okay, guys. So that's, in essence, how you can integrate functions of this form. I hope that was helpful. I will see you again next time.